Good. So let's get started. So Pratibha ma'am, you wanted to show the analysis that you did. Maybe if you can show it here itself, that will be good.
Is the host disabled, sir?
Pratibha ma'am, are you there?
Yeah, sir. Can you hear
Okay,
me?
I am unable to hear you. Your voice is very feeble.
Is it okay now, sir?
No, ma'am. Somehow your voice is.
Is it okay now, sir?
Yes, ma'am. This is very good.
Okay. Sir, can you enable my screen sharing, sir?
Yeah, I did that, madam. So yeah.
Sir, this is the analysis I made for iris dataset, sir.
Okay, madam.
So, I imported data sets from sklearn
Hmm.
and imported the metrics like accuracy score, confusion metrics, and classification report.
Okay.
So then I loaded the iris data set and I find out the type. It is a bunch data type.
Hmm.
Then I printed the data set. It is having four attributes, that is sepal length, sepal width, petal length, and petal width.
Yes.
This iris description, we can see the attributes sepal length, sepal width, petal length, and
Hmm.
petal width. And
Hmm.
there are three. This is a multi-class classification having the iris 50 data. First 50 are of iris setosa, and next 50 versicolor, and next 50 virginica. There are total 150. 150 means
Hmm.
150 records are there. 50 and the number of instances are 150. 50 in each of the three classes. That is 50 setosa, 50 versicolor, and 50 virginica.
Okay.
Then this is the summary status, and no data is missing here. Then I printed the feature names are sepal length, sepal width, petal length, and petal width. And the targets are, as you know, setosa, setosa, virginica, and one more thing, versicolor. Three classes. So we are given first 50 zero class, second 50 class 1, and next 50 class 2.
Okay.
Okay, this is setosa class 0, versicolor class 1, and virginica are the class 2.
Hmm.
And the data shapes are there are four features, four attributes, that is sepal length.
Madam, again your voice went low.
Now, okay, sir.
No,
Sir,
ma'am.
I will
It's still.
connect from other headsets, sir.
Yeah. Okay, ma'am. Yeah.
We'll connect from other headsets, sir.
Yeah.
Maybe because of the problem of the headset. Is it now okay, sir?
Yeah. Yes, ma'am. Perfect.
Okay, that is a problem of my headset. Sir, that means the data shape is for sepal length, sepal width, and petal length and petal width.
Hmm.
Then I tried to plot the sepal length versus petal width in a scatter plot.
Hmm.
That is the X column 0 shows all rows 0th column.
Hmm.
Then X column 3 shows all rows 3rd column.
Hmm.
Similarly, sepal length versus petal width, and similarly for I plotted the first column and the second column
Hmm.
along the all rows.
Yeah.
This is
Why did
the
you do this?
scatter plot showing. In this, we can see the three. There are three classes in that. This three color shows this three different. We are having three things: setosa, versicolor, and virginica.
Hmm.
This is the scatter plot showing. In this, we can see the three. There are three classes in that. These three colors shows this three different. We are having three things: setosa, versicolor, and virginica.
Hmm. Hmm.
Then That is why here we can see in 3 colors.
Okay.
Their sepal length and petal width are shown.
Hmm.
3 classes we are having 3. Here also we plotted, here also we are having. That means this figure shows, I think, this the second class and third class, that is class 1 and class 2 is more linearly nearable features. Like that, can we interpret, sir?
Sorry, ma'am. Can you please come again?
That means here these blue dots and yellow dots are neighbors. More is that shows that any relationship? Can we interpret any relationship on that?
What does it mean?
Is it lying more closer this petal length of this class 1 and class 2?
Yes, the features are close to each other, but if you see that violet color ones, actually you can clearly distinguish from the other two classes.
Yeah, yeah,
Okay, right. So that means you can bring in a clear decision boundary
yeah,
between this the violet color ones and the other classes,
yeah.
but it's difficult for you to define a
From class
decision boundary
with the
uh,
class 1 and class 2.
yeah, between class 1 and class 2, because they are not exactly linearly separable, and you may need an help of defining a very complex decision boundary. A simple linear decision boundary might not be sufficient. Is this analysis clear, madam?
Yes, sir.
Yeah, Anita ma'am, is this fine? This analysis part, whatever I've told.
Sir.
Yeah.
So coefficients, if we plot, we can see that decision boundary now, sir. Now, in terms of this,
Ma'am, your voice is going up and down again. Hello. Hello. You're audible, but somehow your voice is going up and down. Though.
Sir, now any changes there, sir?
That the previous problem of that your voice, this thing again came up, ma'am. Actually, but that's fine, madam. I think there's an issue with the network. I guess maybe.
Might be, sir.
Yeah. That should be fine, madam. So this is clear, right? This analysis, whatever I've told you just now.
Yes, sir.
Yeah. Good.
Then I imported the model selection. From model selection, I imported the train test split. It is 75-25. I put and random state equal to 0. We have imported 75% training and 25% testing training set. Then I imported the logistic regression. I fitted asked the model to model to study using the fit function. Then it predicted the testing function using the when I predicted I printed the y test values, which is given as the x test values. So they are predicted is 2, 1, 0. First one is in class 2, second one is in class 1, 0, like that. I printed the y train values also. We given for y train and y test values. I printed and we see the classes. Then x train values I printed, x test values. Then I gone for, as it is a classification, we can go for check the accuracy. The accuracy is 97.3. And in order to get the intercept and coefficients, from the intercept and coefficient, this is actually the theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3. We have 3 classes separately, theta naught separate and the coefficients of 3 separate classes. Then using the predict proba, I'm able to find the probability of, it's all values are less than 1. You can see that 10 raised to minus 4, 10 raised to minus 2, 10 raised to minus. So all the probabilities are less than 1. And for this is the probability is 0.01688% for it is telling us first one we can see that it is class 2 they are telling. This is a predict probability to class 2. I have plotted only 10 probabilities here. All rows of 10 probabilities. Then gone for the confusion matrix. Confusion matrix for the class in class 1 is wrongly classified, 15 are correctly classified. In class 2 9 are correctly, all the 9s are correctly classified. This we can, when I count this thing, it is like 20 something. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25.
Madam, I think see, I want you to write the code for that confusion matrix, madam, because that is an inbuilt function, right? Because I want you to analyze on how it is working, because if else, then there might be some difficulties as such. So I would highly recommend you to, rather than using that inbuilt confusion matrix, you write a small function on confusion matrix, a user defined function, which takes the same inputs y test and y pred, and you should come out with that matrix of 13 0 0 0 15 1 and 0 0 9.
Okay, sir.
Is this fine, madam?
Yes, I got it, sir.
Because I want you to get a feel of how that is framed, right? So, and tomorrow when something else comes up, you should not you should not hesitate to write a code to implement it, right? So
This I printed the classification report, precision call, F1 score, and this macro precision, macro precision and micro precision I plotted. I got because I have a doubt when micro precision, what is the weight to be given? Is it the 50 or the 13?
total number of test examples.
Only 13.
Yeah, it's not the total number of because the precision you are actually calculating only on the test data, correct?
Yeah.
Then how many number of test examples are there? Those many number of.
That means micro precision 1 is the correct one. Okay. Only this much, sir.
Good, ma'am. So I think this is a good analysis, but I sincerely request you to write that function for deriving that confusion matrix.
Okay, sir.
Because confusion matrix happens to be the fundamental one. If you just have that information, you can derive other classification metrics like true positives, true negatives for each and every class, and then you can derive any other metric that you want if you just have the confusion matrix.
Okay, sir.
So I highly recommend and suggest you to derive that by yourself. Right.
Okay, sir.
Okay. Right. So Anita ma'am, any specific questions you have?
Yes, sir. Sir, actually, I was calculating that. Can I share the screen and show the code?
Yes,
sir?
ma'am. Please go ahead. Yeah. Your voice is coming well now.
Okay, sir. I changed over to that other mic, sir.
Yeah.
Sir, I'm not able to share, sir. Okay.
Why, ma'am? Okay.
Yes, sir. Now it has come. Sir, this was for the iris data set what we had taken. Here, after doing that, sir, that threshold variation I have not done. Right now, considering threshold as a fixed point, and taking the iterations alone only as a different, because I wanted to induce some variations in the data set for analysis. So I minimized the iterations from 10 to 5, and the regularization function I reduced but constant. And with that, some errors I could induce into the data set. And with that, I thought first we will do the TP and the TN calculations, and then further all the metrics to assess. Sir, here initially I took this as 40% of the samples to be in test vector and the 60% to be in the train vector. And here that probabilities I had just read to see whether in really those variations were getting included. Then here I was defining for the number of classes for which the classification has to be done. And the thresholds, because that variation as such I have not done, sir. I wanted to calculate this confusion matrix for the 2 cross 2 and the 3 cross 3 confusion matrix. So here that TPTN, we just declared the initialization I did. And then here is where I was directly calculating the classes, sir. Here in this loop, I was trying to verify for that class, and whenever that class was matching, I was accumulating that data for TP. I had defined a TP as an independent matrix where every column of that TP matrix will be for each class, like probability function itself, sir. So TP will have 3 components for TP0, TP1 and TP2, and FP also will have the same components, and for all the 4 metrics it was defined like that. And then for the confusion matrix, the corresponding TP, once we calculate, I was positioning it into a 2 cross 2 of 3 matrix. It was a block of 3 matrices of 2 cross 2 matrices. So that for every class was one confusion matrix. Like that I had defined the structure, sir. So I was taking those variables and putting it into this 2 cross 2 matrix. And once this 2 cross 2 matrix, or that 3 cross 3 definition, I have some doubts, sir, how to form. And even in this 2 cross 2, the true positive value for class 0 was when both y test and y predict are 0. I just wanted to confirm, sir, this false positive is irrespective of this y test, either it be 1 or 2. Once the y predict is 0 and y test is either 1 or 2, that becomes false positive, no, sir? Because when we are considering one class as 0, because that time you were explaining that the other 2 classes should be totally considered as an error. Correct. Which is not the predicted value. Correct. I took it as a toggle case where it can be either a 1 or a 2. And true negative is both being a toggle case. Y test also can be anything, Y predict also can be anything. Yeah, it can be, right. And false negative is where Y test is 0 and Y predict is anything for class 0. Sorry, can you please come again, madam? Sir, for a TP of 0, both are zeros, sir. And for FP0, for class 0, Y test can be either 1 or 2 and Y predict is 0. And for true negative 0, Y test is 1 or 2 and Y predict also is 1 or 2. And it is nowhere, none of the parameters are 0. Either test is also not 0, predict also is not 0. And FN0, false negative for class 0 is Y test should be 0 and Y predict can be anything, either 1 or 2. Is it correct, sir, these 4 cases? Yeah, that should be fine, madam. But more than that, actually, you can derive the confusion matrix as in the better approach would be to start with computing the 3 cross 3 confusion matrix, madam. So because that gives you a clear idea, because how many number of examples have Y test and Y predict both as 0, and how many number of examples you have Y test is 0 but Y predicted is 1, and how many number of examples you have Y test is 0 and Y predicted is 2, right? So that gives you a clear and a bigger picture when you have the 3 cross 3 confusion matrix ready with you. Okay, sir. I will do that, sir. 3 cross 3.
Right. So
Then,
all that you have to do is you have to just calculate that 3 cross 3, and then from that 3 cross 3 matrix, now it's very easy that and things would be easier for you to compute the true positives and true negatives for every class.
okay, sir. This TP0, TP1, TP2 were clear, sir, because both the matrices, that 3 cross 3 element, that whatever we had got in the class, directly we can fit into. Only this, because here this 1 and 2 are getting merged together, whereas in 3 cross 3, that 1 and 2 will get split separately.
Hmm. Hmm.
So that I have to include, sir.
Hmm.
And since this 2 cross 2 matrix only I had done, only for the 2 cross 2 matrix, that macro precision and the micro average precision I had calculated, sir.
Hmm.
And the weighted average also I calculated, sir.
Hmm.
Sir, this TP, I was just doing the area under curve, sir. Actually, the threshold variation, right now, all this is with a fixed threshold based on whatever is present in that inbuilt function, and only the Y predict values and Y test values I was comparing, sir.
Hmm.
Now, to invoke threshold into this, uh, actually, further based on that threshold variation, only a TPR and FPR can be plotted, no, sir. That threshold looping is not yet done, sir. So for each threshold, all the subsets to be calculated, and then from that TPR we have to calculate, no, sir.
Yes, madam. Correct.
Okay, sir. That threshold looping I have not yet done, sir, in this.
No problem, madam. I think you have come a long way. I think it's only some more, little more effort is what is needed. That's it. Nothing else.
Okay, sir. And I'll try to complete it today, sir. Tomorrow
Uh,
I'll show the results.
So, but I think I'm not sure what is a general practice on using, because this TPR and FPR, in the same way we are calculating the micro averaged precision and the macro average precision. In the same way, I think you have to define an TPR and FPR for that, and maybe you will have a curve for micro averaged TPR and macro averaged TPR, maybe a different AUC curves of both of them.
Okay, sir. Sir, then again, that also for each class we will have to do, sir.
Not each class, madam, because when I'm talking about micro averaged and macro averaged, it's I'll calculate for individual class and I do the average, right?
Correct, correct, sir.
Huh. So I think there
Instead
will
of
be no
PPR,
question of
then we
having an
have.
AUC curve for each and every class.
So then instead of the recall, then we need to use that micro precision what we calculate, sir.
Yes, madam. That's what it is. We need to see whether it's a micro precision. For micro precision, for micro recall there will be one curve, and the macro recall there will be another curve, something like that.
Okay, sir. Okay, sir.
In the same way, you will have the macro and micro for false positive rate also.
Yes, sir. So then that micro recall versus micro FPR will be the AUC, no, sir.
Yes, yes. And then you have like micro AUC and macro AUC. You can separately define and then tell it which how that is how. I'm not sure what is the general practice on how it is to be done, but I think my gut feeling is this. So maybe we'll have a definitely we'll be having a two different AUC curves. One will be like micro and other will be macro average and the micro average. Based on the kind of average that we are doing, we'll have an separate AUC curve,
Okay, sir.
right? So I think you'll be able to do it. That's perfectly fine.
Okay, sir. I'll try to do it tonight and I'll show it.
Pratibha ma'am, is this clear?
Yes, sir.
Yeah, I think you also have to do the same. That AUC curve part. In order to draw that, maybe you need to have what do you say, micro average to precision, micro average recall, and micro average true positive rate, false positive rate, and then for both of them, micro one case one curve will be there, and macro another curve will be there.
Sir, I have a doubt, sir.
Yes,
Sir,
please.
for logistic regression, whether the threshold that 0.5, whether it will change, sir?
No, that is what is generating you different values of no, what do you say?
That means we are having the sigmoid equation 1 by 1 plus e raised to minus z.
Yes, correct.
That when z is equal to 0, that e raised to 0, that is 1 by 1 plus 1, that is 1 by 2, that is zero
Hmm.
point 0.5.
Hmm.
That zero point 0.5 will be constant for all the logistic regressions, threshold value, because
Not constant, madam. Actually, you can vary that. That is what is generating you this. What do you say? That AUC curve we are generating by using that only, no? Because we are having different values of precisions and different values of recalls because of that by varying this threshold.
okay.
Do you remember how did we calculate this PR curve, precision recall curve?
Yes, yes, yes.
Right, because we varied the threshold, and then we had for a certain threshold, say 0.2, point 0.2, we had certain some result of precision and recall,
Yes.
one set of values of precision and recall, and for a different threshold you have a different precision and recall basically. Okay.
Okay.
And the whole idea and the purpose of that exercise of drawing a PR curve was to what do you say, have design an approach to select an optimum value of threshold as such.
Okay.
You got it, madam?
Okay.
You just go back to the talk and you'll definitely be able to understand.
Okay, sir.
Is it fine, madam?
Okay, sir.
Yeah, I think you'll be able to do it. Okay, so now the next step would be to for you to do that AUC curve part for the iris data set. Good. So uh, I'll I'll share my screen. Is my screen visible?
Yes, sir.
Yeah, okay. So this is still running, but this analysis is also equally important for the regression scenario. Uh, what we generally call is there is something called bias and variance. We generally call in the here for the regression scenario. I think that is even that applies the same for classification as well. But bias and variance are the two concepts that we majorly use. So what I'm generally here, my system is little slow, so it's still executing. Okay. So the problem here is in the regression, the linear regression. If you remember, we did it for a linear case. Okay, we were trying to fit a linear straight line. Okay, but as Pratibha ma'am was showing, if you see, there will be certain classes which will not be linearly separable. You need to have an different curve. You need to increase the complexity of the curve basically. Okay, and when you increase the complexity of the curve, what happens is sometimes as the complexity increases, you may find that the training error is coming down, but the testing error or the validation error, what happens is it will shoot up as the complexity is increasing. That means it is more biased towards your or what do you say, it is what do you say, it is overfitting your original training data set. Okay, uh, that is when you call it as an overfitting. That means my the model has become too complex. Okay, and it is showing some partiality towards the training set, and it will not be able to, you'll not be able to generalize well to the other what do you say, that unseen test data set as such. Okay, so you need to decide what is the complexity of the model that we need to choose. Okay, so I'll try to see, I'll try to fix the board Maybe in the meantime, we will restart this session for the time being. Okay. I'll just stop this session and then maybe we'll restart it. In the meantime, I can fix my board as well.
Okay, sir.